Hello everyone, myself Benny John, Assistant Professor of Department of Mechanical Engineering, Rohini College of Engineering and Technology. First of all, today the subject is Theory of Machines, that's Unit 1, Kinematics of Mechanics. First, first this is the terminology for the theory of machines. The machines, first of all, it is device is used for transforming and transferring the motion or force from any input to output. Next, otherwise, it is receive energy from some available form and utilize some work. While there is a engine crank, you are seeing this picture. There's a cylinder is there, next piston is there. While the piston is moved, the crankshaft will rotating, the engine frame will be moving, the connecting rod will connect with the crosshead. Next, classification of motions. First of all, continuous rotation motion, linear motion, intermediate motion, angular motion. Next, kinematic links are element. While it moves to relative some other parts is known as relative links are elements. Next, types of links. First one, rigid links. It undergoes, does not deforms any transmitting the motion. Next, flexible links. It is deformed to transmission of motion. Examples: belt, ropes, and wires. Next, fluid links. It is formed only the fluid and motion is transmitted only the pressure of fluid, that is hydraulic press, jacks and brakes. Next, classification of links. There are four types of links are there. The first one is unary links, binary links, ternary links, and quaternary links. Next, structure. Structure is not only there is no relative motion between them and mean by carrying the loads having a straining action. Examples: railway bridge, roof truss, etc. Next, difference between the machines and structures. Well, the machines, first of all, machine it can move relative to one another, whereas structure cannot move to one another. Machines transform availability into some useful work, but there is no energy transformer into useful work for structure. In machines, they may transmit both power and motion, but structure that transmit only the force. Next, there is a kinematic pair. The two links are elements of machines when in contact each other, that is known as pair. Otherwise, the relative motion between completely or successfully constrained is known as kinematic pair. Next, classification of kinematic pairs. According to the types or nature of contact, there are classified as first one is lower pair. With when the two elements of pairs such surface contact and surface of one element slides or rolls over the surface is known as lower pair, which is example screw pair, tanning pairs, etc. Next, according to the nature of contact, the element is classified as higher pair when the two elements are pairs. They have line or point contacts. The motion between the two elements partially tanning and partially sliding. That is, example is gear toothing, belt, ropes and drives. Next, the classification of pairs according to the mechanical arrangement. First one is self-closed pair. When the two elements are pairs are connected together mechanically, it is known as self-close. While force-closed, when the two elements are pairs, not contact mechanically, but kept contact by the action of external force. That is known as force-closed pair. While the example of self-closed pair is lower pair, but in force-closed, that's the cam profile is follower. Next, kinematic chain. When the kinetic pairs are coupled in such a way that the last link is joined to first link to transmit definite motion, that is known as kinematic. In other words, the links are pairs to transmit required output motion to given input motion. That's known as kinematic chain, but otherwise also known as when the giant link 1 to link 4. That's the mechanism. When the when one of the links of kinematic chain is fixed, that chain is known as mechanism. It may also used for transmitting or transforming form. Example, mending machine. The mechanism may regard as each part reduced to simplest form to transmit the required motion. In this diagram, we can see the follower is moving with wisdom. The sliding players move with one to another. Next, degree of freedom or otherwise mobility of mechanism. The number of independent coordinates required to describe, specify the configuration or position of all the links of mechanism with respect to fixed link at any given instant. Next, Grubler criterion. Grubler criterion is the formula for m equal to 3, n minus 1, j1 minus j2. Whereas m is represents mobility or total number of degree of freedom, n represents total number of links, j1 reference and j2 represents number of joints. If m greater than 0, it gives the mechanism of m degree of freedoms. M equal to 0, it gives statically determines the structure. Then m less than 0, it gives statically indeterminate structure. That's all. Thank you.